Hello to all good people of the world. This is Paul Whittekind coming to you today with the universal law of numbers. And the universal law of numbers is basically it's a representation of the universe that we live in, at least the universe of numbers. And we use numbers to describe the universe. But in this instance, it's the universe showing us the numbers that are describing itself. Let me put that up a little bit. Okay, that's a little better. Okay, so the universal law of numbers is the 369 code. And the important thing to understand, about the 369 code, well, one of the important things for sure, is that when we go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we go here, it's 10, 11, 12, 13, 14, 15, 16, 17, 18. And then when we get back here, it's 19, and 1 and 9 is a 1 again. 27, 28, 2 and 8 is a 1 again. 36, 37, 3 and 7 is a 1 again, and that continues to infinity, as it does in the opposite direction along the minus number line. The same thing occurs going down and up. And down it's quite simply 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4, to infinity. And if we do that, we get 2, 4, 8, 7, 5, 1. 2, 4, 8, 7, 5, 1, 2, 4, 8, 7, 5, 1. And that's exponential growth. And that comes from Euler. And if we want to look at it, I describe it like that. Quite simply like that. And if we want to understand how the numbers go in this upward direction, if you want to think of it in that sense, we can look at it like that, and the numbers are exactly the same. 149779419. If we want to describe it like that, we just show it like that, and it's 149779419 on the top. And nothing ever changes. And that's the important thing about the universal law of numbers. And that's what makes it universal. And that's the part about it that gives us the 369 code. And if you're not accustomed to dealing with reducing numbers, it's all very simple. It's all really just being able to count and add between 1 and 9. And when we take the universal law of numbers, we can look at it like that, if we so choose, and we are going to do that today, because that brings us into the conventional world of mathematics, and all of these numbers repeat themselves just the same. It goes 149779419, and it goes 248751, 248751, 248751. That goes on to infinity. And if we look at that, well, that's the identical to this. These are identical because that's 149779419. That's what that's going to reduce to. And if we go up a little further in numbers, it's going to look like that, and that's going to be the same thing. That's the universal law of numbers code, as is this one. And as is this one. So what we understand is, it's pretty difficult to do arithmetic with such large numbers in terms of numbers like this, I mean, at least, wherever that is. You're in there somewhere. Yeah, okay. So that's just the first page. You can only imagine what the numbers look like if we're on this page. But the beautiful, powerful thing about the universal law of numbers is if we learn this sequence, then we've learned the sequence for all of the following. No matter how large the numbers get, no matter how small they go in the negative direction, they will always follow the code. And if we're doing conventional mathematics and we become familiar with these numbers, just the same way you become familiar with the multiplication tables, etc., and you understand what the connection is and what the relationship is and what the how the code interacts with these numbers, how these numbers interact with themselves, they're always going to be the familiar numbers. Now, what we just do is we go like 4 squared, 4 to the third, 4 to the fourth, etc. But if numbers start to get like really large, at one point we're going to have to be doing 4,782,969 squared, third, fourth, etc., on and on and on, and get these outrageously humongous numbers, which don't necessarily mean anything to us except for the fact that we know no matter how large the numbers are getting, they are respecting the 369 code, they're abiding by the 369 code, and if you were to know how all of these numbers were to, fit together as far as multiplying them against each other and dividing them against each other, etc., etc., and all of the numbers that are hidden in between them, for instance, between 1024 and 4096 is 2048, if you are able to understand how this computer, this calculator works, then you will have a very, very strong grasp of mathematics, and in the least, mathematics learning will become very easy and comfortable for you, because mathematics is essentially arithmetic. These are all the familiar numbers that you find in mathematics. Before we had computers, before we had calculators, even in my lifetime when I started school, we didn't have calculators. Before Pythagoras, even before the pyramids, how old does this go back? How far does it go back? Well, it goes back to the origins of the universe. And it's only humans who discover this. And from this, you can do very complicated mathematics, because what it is there's another one that's following that, and then the next one. What the universal law of numbers is, it's the roots of mathematics, okay? So, what it is, the 369 code is geometry, calculus, algebra, trigonometry, and any other branch of mathematics. It's all embedded within there, and it describes these mathematical families in terms of numbers, and numbers alone. Now, I'm starting to introduce maybe a couple of symbols, like I showed you these radical signs. They're not necessary, because numbers alone will describe our universe. And if this gives life to algebra, trigonometry, calculus, and geometry, that's what gives life to science, natural sciences. And it's only natural because this is the universe, it describes the universe, and the universe, nature, science, God, these are all interchangeable terms in my mind, and anybody can think of them any way they like. But when it gets down to it, I have to show you just how the mathematics works, and you can make up your own minds about all of the things like that. Let's see, I don't even know if you can see the bottom there, but yeah, okay, so it's 3 pi over 2 on the bottom. Good enough. What you can see here is the unit circle, and the unit circle is, well, it's our basic description of geometry, and if you look closely, it's a circle, 360 degrees, 3 and 6 is a 9. No matter which way you divide a 9, you're always going to come up with 9, or 9 by 9 is 1. And I show you that here. So if you divide 9 by any number, as long as they're even slices, 360 degrees by any evenly sliced, any way you want to slice it evenly. If you divide 8, 7, 6, 5, 4, 3, 2, 1 by 9, you're going to receive a 9, except for in the case of 3 and in the case of 6. And when you divide it by 7, you're going to get 1.28571, and that's going to be 714, and that's going to be repeating 285,714 will repeat to infinity, because that's where the 9 comes from. And if we just put 9 in the denominator, the same thing is going to occur. We're going to get 3 6s and 9s. And when we're talking about geometry, it's the 369 code, 396, 396, 396, 396, and that's just the way I divided it at that time, but no matter which way you divide it, you're going to get the 369 code. Okay, so something about the 369 code, if I find the paper without any difficulty, I hope. Let me see. Well, okay, it's coming. So basically what I want to show you is, okay, so trigonometry is the 369 code, as well as geometry. 90 degrees, 9, 108 degrees, 9, 120 degrees, 3, 128.57. Well, we know that that's going to be 128.574 because if we know the 369 code, we're going to get the 248751. When we divide by a 7, 135 degrees, 1 and 3 and 5 is 9, 140 degrees, well, that's different, but because it's a nonagon with 9 sides. But total 1260, 1 and 2 and 6 is a 9. In any case, we can easily see that the 369 code and conventional mathematics in terms of geometry and trigonometry are the same thing because, well, they appear to be the same thing, and they're parallel worlds for sure, and I'm going to hopefully illustrate some of this to you today. How the 369 code is algebra. It is, teaching you algebra. It's a fast track to understanding algebra. It's a fast track to understanding all mathematics, especially with the ability to understand how these numbers interrelate. You will find the same thing reoccurring in conventional mathematics. So this is not the way we typically understand conventional mathematics, because what we do is we overlook this fact. I believe that's the premise of my argument. The premise of my argument is that we overlook the 369 code, and I never took it in college, for instance. Anyway, if we take any number that reduces to a 1, any number that reduces to a 2 or a 3 or a 4 or a 5 or a 6, etc., it becomes that number. Now, I call it 64 is not a 1, it's a 1 number, but it reduces to a 1, as do all of these. But if it reduces to a 1, it will behave like a 1 within the limits of the 369 code. Because the 369 code is not only measuring things on the human scale, it's capable of calculating things on the universal scale. So that's what it does for us. And there are some distinctions, but they always work in tandem. But if I go 64 times 11, that's 1 times 2. Well, 1 times 2 is 2, so that will reduce to a 2. If I go 3 times 6, 3 times 6 is 18, is a 9. Well, that number will reduce to a 9 no matter what. And that's how the 369 code is able to calculate numbers at on any scale. Okay, so today we're going to be talking about algebra. I'm not going to call it algebra per se because all we're going to be doing is looking at the 369 code. But we notice if we have the 369 code, it goes starts off x squared through x to the 7th, then it goes x to the 8th through the 13th, then 14 through 19, and that goes on, 20 through 25. Very good, but it's going to be 2, 8, 5. 1 and 4 is a 5. 3, 9, 6. 4, 1, 7. 5, 2, 8. 6, 3, 9, and 7, 1, 4. So basically, the 369 code that we get from this universal law of numbers is given identically by the exponents. It's also following the 369 code. So if we have a situation like this with a coefficient, those coefficients, they will follow the 369 code. Those exponents will follow the 369 code. And whatever the result of that number is will always follow the 369 code. So I'm going to briefly just go over some of the things I did in the last one. And we won't dwell on them. But the point is, we have this universe of numbers, and it's all a very complicated ocean full of numbers, and it's something that is very hard to get a grasp of. But if you think of it in terms of this, if you think of it in terms of the codes, the universal code, it all condenses down into a very compact package and understandable form, because no matter what we're doing, all we're doing is we're repeating the codes. So if we square the numbers, we're going to get 149,779,419. We know that. If we cube the numbers, we're going to get 189, 189, 189, and that'll continue on to infinity. And these are just different ways of showing you the same exact thing. Because 4 to the third is this, 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 4 to the third is this. And if anybody doesn't know or understand algebra, well, now you should, because that's all there is to it. That's what these x's are. That's all it is. That's all anybody is doing. And to the fourth, so this is 4 to the fourth, they're all 4 to the fourth. These are 4 to the fourth. Different, but it's all the same thing. And all on and on and on and on. So there are different ways of expressing the same exact thing. And if you understand the patterns that the 369 code abides by, you will see how it all kind of falls into place, and it's all very understandable, and there's nothing difficult about it. And if you were actually to delve in there and study and do this arithmetic with these numbers, you would soon find that you're basically, for the most part, able to calculate these numbers in your head, because it's not so hard. Really, all you're doing is using the 369 code. And that's why it's so helpful to learn the 369 code, because it's the origin of mathematics. This is probably what people did in many, many millennia, for millennia. They learned mathematics from this very same diagram. Okay, so I show you that, and I think you get the picture with that. There's nothing complicated about it. But what you see is you just have the same groups of numbers, common familiar numbers, the universal numbers. Just like 1, 2, 3, 4, 5, 6, 7, 8, 9, one-digit numbers. You know, we go to these sets of numbers, and then in order to, build the stairway to heaven, up, 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 it's just copying the same prototype in each and every case. Every step is identical. So what we're going to do is we're going to just quickly, this is what algebra looks like. I guess I showed you that, and we're going to do some of that today. And what I'm going to do is I'm going to go over this, and this is how we use the 369 code as a calculator. And there are different ways we can do it. We can do it using the codes. We can, use the exponents. We can use the numbers. We can, for instance, we'll just do it as I've outlined it. Okay, so we'll go rather quickly, and, I'll point out what's going on. Basically, what's going on is 2 times 4 is 8, 3 times 9 is 27, 4 times 16 is 64, 64 divided 16 is 4, 16 divided 4 is 4, 64 divided 4 is 16. Okay, so we can see quite easily how these numbers are fitting together. Now, if we just do it with the 369 code, we get 2 times 4 is 8, 4 times 7 is 1. Well, that's correct, because 28 is a 1, and 4 times 7 is 28. And this is the key. Now, you want me to, maybe you want it to be a 28 there. I don't know. If it were a 28 there, then the whole show would be over. Because it's a 1, we know that when we get to x to the 8th through 13th, it'll be 1 there. When we get to, 14 through 20, it'll be a 1 there. When we get from 20 to 26, it'll be a 1 there, and it'll always be a 1 there, because that's the universal law of numbers. 7 times 4 is 1, 5 times 7 is 35, is an 8. Okay, so basically, same thing goes on. 2 to the 1 times 2 to the 2 is 2 to the 3. 2 to the 3 divide 2 to the 2 is 2 to the 1. 2 to the 3 over 2 to the 1 is 2 to the 2. Okay. So now we're looking at it like they're x's. Now, once we do that, now we're talking, that's what they do in mathematics. That's why they teach you that. That's where it comes from. This is where all that comes from. So we'll just look at them because they're interesting, and we'll go through a few of them, and you'll start to get a grasp of what's going on. 7 times 7 to the 8th is 7 to the 9th. 7 to the 9th divides 7 to the 8th is 7, because 7 is 7 to the 1. So it's going both ways. Now we know that in mathematics we have reversible operations, inverses of each other, such as subtraction next to addition, such as multiplication next to division, such as derivatives and antiderivatives, or the integrals. Well, in this case, basically what we have is the system is it's the reciprocal of itself. The exponents following the 369 code become the reciprocal of what goes on inside. In any case, what you'll find if you explore this on your own, which I highly encourage you to do, and the benefit that you will attain from that is basically you're going to find yourself being able to understand mathematics and science, natural science, and the universe as a whole. You'll have a different perspective, a big picture perspective that you can actually, have a grasp over and learn on your own, at your own, of your own volition, at your own convenience. And you will find that it's not homework, it's not that chore or that, torture that they put you through in school. You will automatically find that it's extremely entertaining, and it's a game that you can carry on your entire life. What's going on? 3 to the 5th times 3 to the 3rd is not 3 to the 2nd. Okay, so how does it work? 3 to the 3rd times 3 to the 5th is 3 to the 8th. Well, the 8th, x to the 8th, this becomes x to the 8th. It goes x squared, then it becomes x to the 8th, then it becomes x to the 14th, and that's where the 285 comes from. So 3 to the 5th times 3 to the 3rd is this box because it's 3 to the 8th. And that's the 369 code. But you'll see that 3 to the 5th divided by 3 to the 3rd is 3 squared. Okay? So what we have is, what we're learning algebra, but we're also learning the 369 code at the same time. Okay, so x to the 8th times x to the 9th. Well, that would be 2 to the 8th times 2 to the 9th. 8 plus 9 is 2 to the 17th. Well, really we should be doing this. 2 to the 9th times 2 to the 11th is 2 to the 20th. 9 and 11 is 20. 2 to the 20th will fall here because it goes x squared, x 7th, x 8, x 13, x 14, x 20th. 11 and 9 is 20. This is the x 20th line. So that's showing you how the 369 code is doing it, because it is calculating something that's it's the phenomena that's found in our universe. It's these repeating sequences going to the right, to the left, and up and down, and all of these parts are moving together. Now, when we talk about the universe, if we want to learn anything about the universe, if we go to school and we study some course that's a natural science course, well, that's nature. And nature is described in the 369 code. All right. So all of these processes in nature, they're talking about animate objects, living things. The earth, now that's a living thing. The universe, that's also a living thing. So this shows you how the thing moves. It's showing you how it's moving directionally, and I'm pointing that out. For instance, what do we have here? Okay, we have 8 times 32. Well, 8 times 32 would have to be a 4. So what is 8 times 32? 8 times 30 is 240 plus 16, that's 256. 128 doubled is 256. You see how that works? Okay. And we're doing it with the different ones, and it's all very interesting the way it comes together. And it's just, it's arithmetic, but in reality it's explaining something that's a far deeper thing that you may or may not come to understand. But the more you understand math, the more you can understand the 369 code. The more you can understand the 369 code, the more that you can understand math. Okay, what do we have going on here? Let's just divide them. 256 divided 64 is 4. Okay, if it applies on that one, it's going to apply on all of them. What's going on here? 4 times 1 is 4. 4 times 8 is 32. 3 and 2 is 5. And here we see 4 times 7 is 28. 7 times 4 is 28. That's the one. And if we want to do it with real numbers, we can do that too. Okay, so 3 squared times 3 to the 4th. That's straightforward. 3 squared plus 3 to the 4th is 3 to the 6th. And what about here? Now what happens is, okay, what happens is the thing is revolving. So 4 to the 8th times 4 to the 10th is not 4 to the 12th, it's 4 to the 18th. 12, 13, 14, 15, 16, 17, 18. Okay, that's how we compute that. That's how the universal law of numbers, supercomputer of all supercomputers, calculates the numbers. Okay, what do we have going on here? Well, okay, so 1,024 times 16,384. Now that's going to be a big number, but it's about, okay, whatever it is, it's going to reduce to a 7. And the reason it reduces to a 7, because in the 369 code it goes 14977. So that's, well, here, 1497. Okay, so in any case, if we multiply these two together, we're going to reach a number that reduces to the number 7. And also, if we divide 78,125 by 3125, we will get 25. If we divide 279,936 by 7776, we will get 36. So we're just moving right along, and we're looking at how these things all work. 2 to the 2 times 2 to the 5th is 2 to the 7th. And it works going down. So we are confirming that the 369 code does work going down. This is how it calculates in that direction. 4 times 5 is 20. 7 times 2 is 14. 1 and 4 is 5. 1 times 8 is 8. 4 times 4 is 16, and that's a 7. And we look at it here again, and we see that 3 to the 4th times 3 to the 7th would be 3 to the 11th. So we go 3 to the 7th, 3 to the 8th, 3 to the 9th, 3 to the 10th, 3 to the 11th. So 3 to the 7 times 3 to the 4 is the same thing as 3 to the 5. Nine times 9 is 9. You know, nines can, you can do it with the 9 or not. You don't have to, because 9s are always going to be 9s. You can't do anything with the 9 to change it. And 1 times 8 is 8. 7 times 4 is 7. Wrong. Because I did it wrong. 7 times 7 is 49. That reduces to a 4. 4 times 5 is 20. 7 times 2 is 14. 1 and 4 is a 5. And we're going to show the ones going down and understand how that works. So you can do it with thinking of it in terms of the universal law of numbers 369 code. You can think of it in terms of the exponents with the x's, or you can just think of it in terms and use it in terms of multiplying large numbers by large numbers. And that apparently is what that amount probably was. Yeah, 1,024 times 16,384. It's 101.6 million. Well, 167,77216. Okay, that is 16,777,216. And I should have known that one because that's one of the familiar numbers. but, okay, which is 4 to the 12th, because 4 to the 5th and 4 to the 7th is 7 plus 5 is 4 to the 12th. So you can see that this is a very powerful calculator, and I'm just going to show you, let's do it with some real numbers here. 16 times 256 is 4,096. 64 times 4,096 is 262,144. Just like 4 times 16 is 64, and 64 divided 16 is 4, and 64 divided 4 is 16. And that's just showing you it with the universal law of numbers. 5 times 2 is 10. That's a 1. And I'm getting there. There's more of this because we're going to do it sideways too. So feel free to do some of this arithmetic in your head as you're looking at them so you understand them. 7 to the 11 times 7 to the 13, that's 7 to the 24. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 7 to the 24. Okay, so I think that sort of covers that. Now we're going to do some, and we're going to see if it works going side to side. And of course it does, because it's the universal law of numbers code. But it does it in its own way. But here's the universal law of numbers, and we know if 2 times 4 is 8, then 4 times 7 has to be a 1. 8 times 1 has to be an 8. 7 times 4, 28. 5 times 7, 35. 2 times 4, 8. Okay, so now we're going side to side. And side to side is interesting because it has some of its own, it does the same exact thing because it's the universal law of numbers. 2 times 4 is 8, so 2 squared times 4 squared is 8 squared. 2 squared is 4 times 16 is 512. Okay, 4 times 16 is 64, and 8 squared is 64. Thank you. Okay, it's easier to see here. 16 times 256 is 4,096. 128 times 16,384 is 2,097,152. And the numbers are going to work that way too. But they're going to work that way. They're going to work the way they do. And all we can do is, if we learn them and we understand how the numbers work together, we will understand what's going on in this world, universe that we call math. And I highly suggest people do learn this because it's a beautiful thing. It's the truth. Okay, now let's look at it. This is a little bit different, but we can see something going on. 2 squared times 5 squared. Okay, that's 4 times 25. 4 times 5 is 100. 2 squared times 5 squared is 100. It's 1 with 2 zeros. 2 squared times 5 squared is 1 with 2 to the 3rd times 5 to the 3rd is 1 with 3 zeros. 2 to the 4th times